The book says Vy, but who cares? You can make it My if you want to. Oh my. Why is that homogeneous? That was the original definition of the word homogeneous. Why is that homogeneous? The one that's highlighted. Or homogeneous. Every single term in there is what degree? Second degree. I love it. Yeah, that y to the fourth over x squared is definitely weird, but that follows the pattern. If I divided everything by x squared, that would be y to the fourth over x to the fourth, which is really what homogeneous is based on, is having y over x. That's part of your thing. Okay, enough of that one. So I would still try it if I were you, but I just want to let you know you will get to a point where you're like, what the shit? I apologize. Let me see. Before I forget, let me give something back. More people came, aren't there? All right. So it is completely wide open. We could try. I have the answer key for this, and there's 6 pages to it. Yay. Just to let you guys know. Jeff is so neat. I thought for sure I had the answer key for this already, and I didn't. So last night, this morning, I created it. Yay! So I'm a little crazy, but that's okay. So we can do problems from this. We can do problems from the last test, whatever test we can do any damn thing from this semester you want to. Yes.
Can you do like solving a DPQ with a class transform?
Solving a
DPQ, like
a differential equation. Okay.
Differential equation with.
Part of me thought you said like a system of differential equations. Okay, so let's see. So what if I had make one that would work? That would be nice. Yeah, I don't know. If I'm just gonna make one out of nowhere, it could be well.
There's one on the final, number 10.
True, we could do the one on the practice final. That's fine. I just kind of like to leave that because I have the answer for it anyway. But or did I make one? Is that the same?
Pretty close. You're just missing the plus 2 ones.
Nita. And then I'm gonna let this be sure t e to the t. So the main thing for you guys, I was nice to a point. So I'm gonna let you use that Laplace transform worksheet. That's got all the Laplace and inverse Laplace transforms. The one thing I made you memorize is the Laplace transforms for derivatives. And I'm pretty much only gonna go to a second degree for this kind of problem. Because again, we only have so much time. So if I apply a Laplace transform to this, and by the way, if I didn't say use Laplace transform, what method would you use to solve this? Constant coefficients. So it leads to each of the stuff, right?
Yeah.
And to get the YP, I would use undetermined coefficients. So just a bunch of coefficients. Yeah. Okay. But this problem specifically would say use Laplace transform. So we'll do a crazy L to everybody. What does y double prime become?
S squared y capital Y of x minus s y of 0.
Good.
Minus y prime of 0.
Minus y prime of 0. I love it. And then you got, well, this is all for this guy, right? Okay, now we do this guy. So now it'll be minus 3. Well, that would be for this. So minus 3, what's the first piece of this? It would be minus y of 0, correct? So now it's going to be plus. Yeah, minus 10 big ass y of s equals. Well, now what's this going to convert to? All right, let me stop right there. Is everybody cool with that? And again, you could be as nicer to yourself. you can write y double prime, y, and then multiply each thing, multiply the 1 by -3, multiply 1 by -10. Because one easy mistake to make is to forget to multiply and you put like, it's supposed to be plus 3y, you put a minus 3y, that's going to mess everything up, potentially, right? So you can be nicer to yourself if you want to. So what does this become?
Over x squared.
Yeah, it's been shifted, right? I like it. So hopefully everybody understands when I ask you to transform this, you can't do the product of the transforms of each. Same idea, because it's based on integration, and I can't integrate a product by multiplying the integrals, right? We don't have that kind of rule. So I think, so what do I need to tell you?
What y0 and y.
Yeah, to be really honest, I don't have to, but that would make this really, really gross. So I will try to. So let's make, what do you guys, it doesn't matter to me. What do you guys want?
0.
It's up to you, yeah. We can make them 0, 0 now. So you know I'm not going to.
0, 1.
0, 1? Sure. Okay, let's see what happens. So this will be s squared ys. This is 0. This is 1. Minus 3s ys. And this is 0. Minus 10 big S y of s. Okay. You guys all okay? Now me, I was always weird. I loved partial fractions, so I loved the shit out of this because it just makes it into a partial fraction kind of algebraic problem. But I understand if you don't like partial fractions, then you really, I mean, that's really what a lot of these boil down to. It's partial fractions. So, are you guys? Let me see if I can write less. You ready? Okay. Ys equals. I would add 1. And then I would divide by s squared minus 3s minus 10. Is that cool? I would add 1, and then I would divide both sides by s squared minus 3s minus 10. Now, what seems like a bad idea, but it's actually a great idea. You want to combine these two. Because then you only have to do partial fractions once. If I leave them separate, I have to do partial fractions twice, yes? Let me stop for a minute. I'm doing this problem. I really shouldn't be. I should be letting you guys do it, but you have two options here. You can either leave them separate, then there's two problems. The partial fractions, both of them. I prefer slam them together, which feels backwards, but then you only have to do partial fractions once, yeah.
I did try to do that on like one or two of the tests, and I put the wrong answer from doing that.
Well, sure. No matter what method you use, you can get the wrong answer. So I'm not sure what kind of mistake you made, but don't get me wrong.
I don't know either, but like when I plugged it into like the programs of like what I was doing, it was still outputting the wrong answer, but only when I like done the separate partial fractions, I got the right answer.
Okay. So you have options here. If you would rather keep these separate, you can. I'm not going to force you to put them together. Yeah. So let's see. This would need an s minus 1 squared, right? Which would be s squared minus 2s plus 1 plus 1. Alright, so let me make sure everybody's with me. This guy would need an s minus 1 squared, right? So I'm going to give it to him. That would be s squared minus 2s plus 1 plus 1. I'm going to combine the tops. Okay, I'm just trying not to write that much. How do I factor s squared minus 3s minus 10?
Minus 5 plus 2.
Kick ass. And now, of course, is the partial fraction step. So now I'm gonna have,
When you use the s minus 1 squared, we're gonna get 4 parts, right? For this one.
yeah, it's gonna be, yeah, exactly.
So we'll have.
They're all gonna have linear tops, yes?
So we'll have an s minus 1 and an s minus 1 squared. That's really like a plus 2ab plus b, like a squared plus 2ab plus b squared, like when you factor that all out.
Let me write it down.
Okay, if you FOIL out s minus 1 squared
Yes.
for one of the fractions, do we want to put above it just d, or do we want to put dx plus?
So if you add this, you would put as plus b, yeah?
Yeah.
But then, since this is factorable, I can actually break all that down, right? Which is really what we want. I'm trying to break them all down. So if I stop here, this is what I would put up here, but then this would be its own problem. I still have to break this one up. Does it make, I'm not really sure I know the question you're asking, but I think it's
In the
this.
bottom of the fraction, it tells you that you would need 4 other fractions to break it up into.
Yeah, this here, yeah.
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 One is s plus 2, one is s minus 5, one
Yeah,
is s
so let's
minus
write it
1,
down.
and the other one is s minus 1 squared. Yeah, that b, why isn't that b a bx plus c?
Ah, okay, real quick. Sorry. Okay, you ready? Okay. So if I thought it should be this, okay, this is gonna be a little hard. Let me give myself some numbers just to show you how this would work. So let's say I have 4s plus 5 over s minus 1 squared, yes? Okay, isn't this s minus 1 plus 3s plus 6? You with me? And then couldn't I break this up? So this would be 1 over s minus 1 plus 3s plus 6 over s minus 1 squared, yes? I could keep going. This would be, I don't know if you guys are really with me or not, but this would be s minus 1 plus 2s plus 7. And then I could break, and then I could do the same thing. Does that make sense? So it's the understanding that I don't need this. If it was this, I could break that down more again, right? So I might as well write my desired answer completely broken down. Yeah.
When would you need it to be as?
You would need it. Now, what is it about this problem that tells me it can break down? Because this is factored. So therefore, I could write it so that one piece of this factor cancels, and I could do that over and over and over again until I get it down. Let me see if I can make it an easier problem real quick. This is kind of nifty. Let's say I have this. Okay. This is s minus 1 plus s plus 2. Is that it? Is that cool, everybody? If I wanted to be really weird, I could just rewrite that like that. Anywhere I see this in the universe, I can write that instead. How often is it helpful? Not very. But then I can write this. Yes? And then one of these cancels. So I get 1 over s minus 1. Jeff, you could do it, can you? Plus s plus 1 over s minus 1 squared. Oh, 2. I can almost read my writing. Okay. Real quick, just stay with me. Then this will be s minus 1 plus 3, yes? You with me? Which would be 1 over s minus 1 plus 1 over s minus 1, yes? Plus 3 over s minus 1 squared. I can always get it down to, and of course I can combine those, to a single number over s minus 1 and a single number over s minus 1 squared, always.
Okay.
So why not just start there, right? Yeah. But it's a beautiful question. I need you to understand. And I decided to take the time, but it takes a little time to show you why that's true. Okay. So we want our answer. In fact, the numbers we get are just going to be whatever the numbers would be if I did write this. I just have to keep going. It would suck. Yeah. So I might as well just go straight to the answer. Laplace sucks for me because my S's look like 5s, bless you. Okay, who's got the quick way to do the next step there? Who's got the way to move me? What's that?
There is no quick way, there's only pain here.
There is no quick way. I was born in a different equation. Yes.
So, you find where it equals 0 for each
So-
element?
Oh, no, we're not there yet, but I agree with you. Real quick, what's the A has an S minus 1 on the bottom, correct? So it's gonna pick up everything else. Do you understand what I mean by I said it? So it's gonna pick up another S minus 1, an S minus 5, and an S plus 2. Okay, good. I think everybody gets that idea. The B is gonna pick up an S minus 5 and an S plus 2. You turn my paper this way. The C is gonna pick up an S minus 1 squared and an S plus 2, and the D is going to pick up an S minus 1 squared and an S minus 5. Okay. Now here's where people were not nice to themselves. Dear God, we're going to do what I think Clara just said. Dear God, we're not going to multiply the shit out. Okay, what we're going to do, first I'm going to do something to make this better. I'm not sure what to do to make this better. It's going to be okay, Jim. If I let S equal 1. 1. So if S equals 1, this would be 1 minus 2 plus 2, yes? Which is 1. This would be 0. This would be 0. This would be 0, yeah? So I get 1, because when I put an S in, I get 1, equals negative 4 times 3 times B. I don't mean to be flicking everybody off. Okay. Is everybody with me? Do you guys see that? I could have let S be 5. I could have let it be negative 2. Anything that's going to make stuff 0, it kicks ass. Because what sucks about this? Everything, Jeff. No, what really sucks about this is all the freaking unknowns. Holy shit. If I can kill some of them, then I can focus on the survivor. So the only one that survived is B. Now I can figure out what B is. And then I revive the other ones, right? Over and over. Thank you. Thank you. Yeah. You have to excuse. I'm really sorry. I'm a little loopy. I'm very sorry. So what would I let S equal next? Holy shit. So if S is negative 2, I get 4 plus 4 plus 2 is 10. Look at me go. So what's the only survivor is if S is negative 2? D. So I'll get 9 times negative 7. Man, you made a great problem, Jeff. Negative 63D. Is everybody excited about this? I need you to understand, we're getting fractions. Who gives a shit? Right? We're not going to have to work with them much. So D equals negative 10 over 63. That's awesome. And I would just keep going, yes? Okay, and every single one of these, the devil inside. No, every single one of these. Are you guys okay if I, no, listen, you just keep going. You get, and then, for example, if we do this 1, every single one of them works the same damn way. Well, not really, I'm sorry. Almost every single one of them. This one's going to be a little different, yes? So let's do B. That's what I'm going to do. So I get negative 1/12. I'm just going to write it weird, and I don't care. Over S minus 1 squared. So then I have to inverse Laplace that dude, yes? So there's going to be negative 1/12. And how do I inverse Laplace 1 over S minus 1 squared? E to the t, and that's the shift. T, I love it. Which I kind of expected. I had to get a TE to the T term because I had a TE to the T term as the answer. The rest of them are going to be what? the rest of them are gonna be each of the, either the 5t, each of the negative 2t, yeah, so the rest of them are gonna be nice. Yes, kind of what these, once you figure out what each of these are, then the inverse Laplace, you apply the inverse Laplace, and you're done. So the one major thing I think is going to help a lot of you guys out, and please, dear God, if you don't understand what we just did, let me know, because this saves your ass so much. Letting S be a number that will kill some of your terms, and then you have one letter left. Oh my God. So much better than setting up some big ass matrix. Now you could set up a big ass matrix and chuck it into your calculator. I don't give a shit. But you better know how to convert those to fractions. You know what I mean? You're going to get a bunch of decimals in there. I don't need that. I want to see some fractions. Okay. You guys with me? Is that okay? Yes.
So was the algebra.
Huh?
So was
Oh
the
yeah,
algebra.
I know. Trust me, man.
The cover-up method, I do that sometimes, the cover-up method.
Yeah, totally.
Yeah, cover
Dear
one
God.
side.
Because part of the problem with any math is students think I'm supposed to have this whole thing in my head. Holy shit. I think I was lucky. I think I naturally was able to break stuff up. Sort of like people that can naturally draw because they can see the shapes that create something. I can't do that at all. I have no idea. No idea. But I was born with an ability just to break stuff up. So math was a little easier for me because that's what it's all about. Can you break this down? Can you break it up? Can you look at just one piece? The rest of it doesn't matter. And I've noticed some students can't do that. And that makes math hard. Okay. Is that okay for that?
Yeah, so when we're solving for A, right, since we already used our, well, we can't really just do anything with A to cancel it out. Wow.
Yeah, because A's got all three of these in it.
Yeah, so would
But
we-
at that point, I will know B, C, and D, won't I?
so we just use a random point.
So what I would do is like, do you see how I get AS cubed?
Yeah,
And do you see how I get CS cubed?
yeah,
And see how I get DS cubed?
yeah,
So then A plus C plus D would have to be 0, right?
yeah.
Do you see what I mean? So the beautiful thing is once you got every single letter and you're like, oh, that last damn letter, shit, who gives a shit? That's the only letter you don't know. So you take any relationship you can. And that's the one relationship you have to use. Does that make sense?
Yeah, yeah.
Yes.
Look at the coefficient at that point.
Yeah, exactly. So I always pick the largest degree term. Because that's the easiest one to just pick off at the beginnings. I don't have to FOIL the whole damn thing out. I just have to look at the largest degree piece. Does that make any sense? If it doesn't, let me know.
Can you do that for A? Can
Yeah,
you,
let's
like,
try.
write
All right, so real quick. The only letter I don't know besides A right now is C. How do we get C if I let S equal to what? 5 won't mess with C, correct? So if I let S equal 5, this will be 25 minus 10 is 15 plus 2 is 17. Is that true? Help me out. And this will be 0, 0, 0. So this will be 16 times 7. Good Lord, Jeff. Okay. 112, is that right?
Yeah.
All right. I'm almost certain it's something like this. Okay. So then how do we get A then? Well, does everybody see what I mean when I say there's AS cubed? See, B is not a cube, right? No cube. So AS cubed plus CS cubed plus DS cubed has to be 0. Why?
Is there no S cubed?
No freaking cubes, yeah. And I know C and I know D, so then of course I can get A, right? Take C and D, and I have a very exciting time adding them. And then I just change the sign, right? Put it on the other side. You guys kind of with me? Okay. Real quick. Please tell me you guys know this because I'm not interested in, do you know how to do LCD? Because if you don't, I almost don't want to know, but if I just put in here, it's pretty cool. I'm going to move them over, so I'm going to change the sign. So I'm going to do 10 divided by 63 plus 17 divided by 112. Okay. No, it'd be minus, Jeff. You can do it, buddy. You can do it. So I changed the signs because I moved them over. Is that all right? So A equals this. And you could say, well, Jeff, didn't you just say you don't want to see, well, let's see if this calculator can handle this actually. It can. Look. Yay! Did everybody know about the fraction button?
Yeah.
Does everybody know about the fraction button? Fraction button's good to know. I tell students that and they're like, well, I didn't know that shit back in like pre-algebra. That would have been awesome. That says 1 over 144 by the way. Okay, okay. So please, please, please do that for yourself. I saw people setting up all these crazy equations and getting lost in them. Let S equal a number. That kicks so much ass. Then you can focus on one letter at a time. Okay. All right, where to now? Yes.
Could we do problem like number 9 or just number 9, a Laplace transform with like piecewise? Looks like a system.
Oh yeah. Here. Okay. So let me write that down real quick. Paper rules my life. Okay. Whatever. 2, 0 to 3, and then -2 raised to 3. Woohoo! Okay. So I just started tacking it with the Laplace. What would that look like?
0 to 2 equal -3 dt plus 0 3 to infinity,
Good?
and then just
Yeah. So the funny thing is, once you integrate one, you know the integral of the other one, because they're both the same. I mean, if I take the negative out, right? Once I integrate one, I got the other one. The only thing that's different is what I'm plugging in. Is everybody with me? Is that cool? Some people weren't really sure what the first step would be on this. The first step is just applying what the Laplace transform wants to do. So it only exists up to 3 for this guy. Okay. And this one starts at 3. Okay. I can do that. And all right, and then what do you get when you integrate this? So what I always do is, okay, you put 2e negative st down, but if I take the derivative, I get a negative s out, so of course I gotta divide by negative s. Cool. And isn't that gonna be the same thing over here? So all that's different is what I'm evaluating from and to. And I know technically this should be t limited. Who gives a shit? Right? We're past all. We already got a t, so we don't want to do that. Too much t. Although I like t, that's okay. Not too much. And now you just plug that stuff in there. Do you see how you're going to have a couple like terms? Because they both have a 3 input. You're going to have some like terms you can put together? Yeah.
For the integral, that negative, did you take it away? Because there was a.
Oh, I need, yeah, that minus should be there, right? Should this be a minus?
So the 2's negative, right?
Yeah, I took the 2 out, took the negative out, so that these were exactly the same integral. Yeah. And now, of course, these 2 cancel. Chabow! Is that all right? I mean, really what you got to know, you're not going to get that problem. You're going to get a problem like that. So whatever the hell I give you, you're just going to set up its own integral, and I gave you the limits, right? I tell you what the limits are in the piecewise. So then you just attack each one. This one's kind of nice because they both have the same inside, so I don't have to integrate once. I just have to put different limits in. That's nice, yes.
Does it matter if there's limits when doing this, whether or not it includes that value? Like it says less than or equal to 0 and less than 3.
Oh,
Like that doesn't matter.
real quick, you guys know this.
Yeah, that does.
You guys know this. Integral's area, correct? What's the area? So area is the rectangles, and then we look at infinitesimally small, correct? Do they ever get to 0 width? No, they get to dx width. That's the whole idea, right? So how much area is there above any specific number? What's the width of 3? You can do it. What's the width of 3? 3 goes from 3 to 3. So what's the width? 0. So it wouldn't change shit. It doesn't matter where the equality is. I think that's what you're really asking.
Yeah.
It wouldn't even matter if there wasn't an equality. You guys have integrated piecewise functions directly, right? Like You could have a step function, yes.
Mhm.
What would the integral of this be? It would just be
That.
these stupid rectangles. Area. You're done, right? Because that's all integral is the area under something. Would it matter if both of these are open? Nope, because what's the area of this line?
No.
0, so it doesn't do anything. That's kind of weird. It's a little weird, but. I like that. That could be a tagline. It's a little weird, but. Is that better? I mean, so no matter what function I give you in the piecewise, that's how you set it up, and then you just attack each integral directly. This one was nice because it had exactly the same integrand. Okay. What else looks weird? Number 11, just to let you know, well, I'm going to give you the answer key, but it's going to have one where one answer has zeros forever after a certain point. Real quick, there's no way you can necessarily notice this ahead of time, but what happens if you let y equal x? What's y double prime? If y equals x? 0. So if y equals x, here, Jeff. There you go, buddy. If y equals x, that's 0. If y equals x, what's y prime? 1. Minus x plus x? 0. So y equals x is an answer. So when you do your, there's no reason you should notice that ahead of time. 0 reason you should just know that ahead of time. But it makes sense. You should get y equals x. Y equals c1x is one of your answers, one of your power series solutions. It just happens to have all the constants of 0, except for 1. Yeah. I guess so, yeah.
Would it be a 3-variable system for equations?
I'm sorry, do anything?
For the test, like for number 4, will it be a 3-variable on the test or
3 variable.
like system?
Sorry, let me see. Oh, here. No. Dear God, no. Just remembering how to do this should be plenty, because we didn't have a quiz on this, which was nice at the time, but now you're like, oh, I didn't get any extra practice with that, so that actually kind of sucks. Yeah, so, no, I'm going to give you 2 by 2, 2 variables, 2 equations, 2 unknowns. So now just remember how to do that. And now some of you guys are going to know how to do it with matrices, possibly. Although that one will be a little bit more involved, because it's not homogeneous. Still doable, just a little worse. That could also be a tagline. I think number 5 was one of the worst. Oh my gosh. I don't know if anybody tried 5, but just to let you know. 5's a trip.
Is 5 just reduction of order, or am I crazy? Or I'm crazy.
Yeah, now as I say that, I remember that you guys can do the shortcut. Yeah, that's assuming y equals u, e to the 2x. Yeah, so yeah, you could do the shortcut. I just remember. So, yeah, I guess it won't be a error for you guys if you just use a shortcut. Yeah.
It's okay to do the shortcut, you don't want the full.
Yeah, yeah. Somebody asked me earlier. It's okay to use a shortcut.
Okay.
Yeah. Okay. You'll see why. In fact, number 5. Oh, is this all of it? I feel like it was a bear. Okay. Yeah, I guess it wasn't too bad. I don't know. I think you guys are probably calling this a bear, but that's that's what it looks like in totality, right? But you're right, you could use the shortcut. I just don't have the shortcut memorized, so apparently I'd rather do all this than just take a moment to memorize the shortcut. But you know, that's the way it goes. I showed my pre-calc class this because we were talking about, the last thing we had to talk about was summation symbols. And they really appreciated me showing them this. Very sarcastic, I was there. There's the one answer. Let me go ahead and give this to you so you have a moment or you have several moments to look it over. Does anyone have a specific problem or a general type of problem that you want to look at? Question? Yeah?
Do you know what chapters your class will cover yet?
7-3, right? Yes. Up to 7-3.
I'm gonna do first task. So we're gonna do like the last step first and the earlier stuff. second.
Oh, yeah. Oh, I'm
So
sorry.
it's like wondering which chapter is the first lesson.
You're asking me specifically what's gonna happen Tuesday and what's
Yeah.
gonna happen Thursday. I don't even know yet. We're all gonna find out together. I'm sorry, I haven't made the thing yet, so we did talk generally about, I'm gonna put more recent stuff, so like, I'm gonna put Laplacian stuff. So, straight up conversions, I'm gonna put solving B's with Laplace. Maybe there's gonna be a partial, a piecewise. Oh.
Oh, sorry. No, I said right.
Oh. I'm feeling like I'll probably, for the first day, I'll go back to about 4.9, maybe. Let me think. I really have to put it together so I can make sure the balance is right, you know what I mean? Because I don't wanna make one that's, well, this one would take an hour and a half, but we don't have that, so do what you can. So I gotta make sure the balance is right, but I'm thinking I'm gonna go back to at least section 4.9 for the first day. Right, and then I'll see if that kind of feels like I don't wanna leave too much for either chunk, does that make sense? So that gives you a bit of an idea, but I can't tell you exactly, who's the words you give me.
Do you know what the whole problems for chapter 8? Yeah.
Oh, shit, okay.
Oh, they are?
Yeah, thank you, I thought they were. So let's see. Let's take a look. Get out of here. What are you? Microsoft, leave me alone. Okay. Am I in you guys? Yes. Yeah. Okay, so my WebAssign people, right? You guys are like, this guy, why does he treat us like this? I'm sorry, I just don't think about WebAssign, I'm sorry. Somebody has reminded me to build those if you wanna do chapter 8 for extra credit. I haven't built those in the WebAssign yet. Yeah, so we'll just keep it like that, since I'm gonna make it extra credit anyway. That's not a ton of problems. And of course, like I said, if you've taken linear, you might as well do it, because it's not that big of a jump from what you've done in linear. Okay. And just in case you didn't see this earlier, I am gonna put this up in Canvas, but this is my schedule for next week. Bless you. So wherever it says extra office hours, that literally means, on top of, because this isn't my complete schedule. I'm gonna have my normal schedule, normal office hours. Everything on here is extra or when I'm doing a final. So if anybody here has a makeup test they need to do or something, you could just pick a final exam day and then let me know. And then you can take it then. I've kind of lost track. So there's our first part of the final and second part of the final. You guys get to be my final. Yay! And then the next day after that, I go to Iceland. Yay!
You going to Reykjavik?
Reykjavik, yeah, you gotta fly into there, and then I'm gonna kind of like drive around the outside of it. It's like, oh my god.
As a vacation or?
Yeah. Yeah. I need. So, I've never been, so we'll see. If you've ever been, I'm open to suggestions, but I have a whole list of stuff I wanna see, so. So feel free to use any of those office hours. I put the rooms there so you know where I am. Obviously, Thursday is beautiful because I'm done with every other class. So I got a full hour in here for extra office hours, yeah.
Extra credit mark to the first one or the second one?
The final. I can't remember now. I think, did I make the due dates and WebAssign on Tuesday? I didn't, so somebody please remind me. I so the last time I taught this class, I gave the final on one day, it was great. This is my first time doing 2 days of final. So my brain wasn't thinking Thursday is the actual final, so I can push that back to the 23rd.
Okay.
If somebody helps me out. So, going back to the practice final, anything else you wanna look at, or if you're looking at my work, does it look like I got it right? Let's see. The first question is a little bit, I intentionally left it very open. If I give that kind of question, I kind of have a certain number of things I need to see, and then if you give me more, I might give like an extra credit or something. The very first problem, right, where I just say, tell me whatever the hell about this problem you can. So what form is it in, what method could I use to solve it, that kind of thing, right? You see, what was the other thing? This should come back to you pretty quickly, right? This one you should be like, please, dear God, Jeff, give me one of those. When you do this one, the variation of parameters is not necessarily a choice. You have to do the variation of parameters, right? Because for Cauchy-Euler, I can't really do undetermined coefficients. There are very specific situations where you could, but they're not the easiest things to categorize. So, Bernoulli's is a little bit like class adjacent almost. We didn't really do a ton with Bernoulli's, so I'm probably not going to give you Bernoulli's. So if you study the hell out of Bernoulli's, I'm sorry.
I was about to. I don't remember.
I understand.
I don't remember.
Yeah.
Wouldn't Bernoulli's still be solvable just doing Cauchy-Euler and variation of parameters? Or am I-
That problem I gave, would Cauchy-Euler work for this problem?
the multiplier by X or something?
But then the degree doesn't match the order, right? Yeah. So, I mean, could you have a problem that you could do Bernoulli's or something else? Yeah, of course. So, that's one of the very first things we talked about in chapter 2 was you could have a differential equation that is of many forms. So the most simple one we see is separable or linear. You have some that are separable or linear, you can do it either way. So of course I would pick freaking separable. Because that's just straight up integrating, which is awesome, right? But linear is kind of cool too, because once you figure out that factor, you're like halfway done. Yeah. So it's up to you. Be ready for, you know, like a constant coefficient problem where, or even a Cauchy-Euler, where you have to know some forms of factoring. Yes? So like part G, what would the ox be? Yeah, m to the fourth minus 7m squared minus 18, right? So then you can do that one level, and then of course you have to do it again. You're gonna get complex answers, blah blah blah. But I could give you one. I've given you this before. That's grouping. I could give you one that's the AC method or whatever they call it. I call it surefire method. But, and you're all like, "Thanks, Jeff, man. That's what I want." I got DE to worry about, and then you throw in factoring. Really too damn bad. You gotta know your factor. Factoring is stupid important. Say again?
What was the third factor you mentioned? The surefire factoring?
Yeah. So, Yumita's on it. She's like, you're probably gonna do that one. So I always go to this, because this is one I know that works. Do you guys remember the method for that? Now you could just do trial and error, which I wouldn't blame you if you just did that, but this is where you do negative 24, factors of that to add to be 5, you break up the middle term, and then you can group, yeah? Now to be honest, I don't do that shit. I change the problem, then I factor this, and then I bring a factor of 4 back over here. Done. Okay. And that method's called the. You're gonna love this shit. That method's called a Texas slide. I don't know why. I don't know why. It just is. We weren't there. We couldn't go. That's dumb. So that's what it is. And I don't care. So some of you guys do stuff, and you see me. I wrote. How did you do? But I didn't take points off because all I care about is that you're able to factor, right? So you can have your own method. You can have your own trial and error. Some of you guys wrote some shit. And I'm like, I have no idea what it means, and I don't care because factoring is a low-level thing. You should have a way to factor everything. Yes.
I know I like memorized like any of the forms of factoring in Qubit, so all I do is I just look at the last term and find out the one term I can like easily figure out and then just like have that X minus that and then figure out
Okay.
like,
Yeah, there's all kinds. Yeah, just factoring is one place where you can kind of really make it your own. There's so many different ways to factor stuff. It's crazy. Just you might, I besides the key, I don't bring much. The key and me, that's what I bring. So if you guys don't have anything you want to look at, yes.
How do you do resistance and medium keys?
So there were several levels of that, remember? So the very first level was the f of x, y had to be continuous and its partial with respect to y had to be continuous way back when. But then you get to the point where it's, it depends what kind of problem you're talking about. So just to show you, I think, did I put a problem like that on the Praxis final? Because it really depends what type of equation you're dealing with. So this is one here. No, I'm sorry. This is the existence of fundamental set. That's not what I want. Where was the? Just to give you one example, I'm not overly concerned with those. I forget where the other example was. Dadgummit. All right. But the more recent one had to do with each coefficient function had to be continuous. Just want to see where that was. Here we go, 119. Here we go. Yeah, so if I'm given this form, so this is before I've divided to figure out P of x and Q of x and all that kind of stuff. All of the functional coefficients have to be continuous on whatever interval I that I want to use. And of course, the extra thing is, and this is the one that everybody really remembers normally, is whatever the first function is cannot be 0 in that interval. Because that would make this become not really this degree sometimes. And I can't really get totally into this, but that allows for other curves to work if this is sometimes 0, because it takes away this restriction. I don't know if you guys are with me. If you look at each of these as being a restriction, like to make this function, I've got to have a slope with something, I've got to have a derivative, and so forth. So if sometimes this is 0, that goes away. So then that allows for multiple different curves to work for that through that point. So this was all the coefficient functions have to be continuous, and the first one can't be 0. That was the most recent existence uniqueness theorem, if I remember correctly. Much simpler than the very first one, which was in a region around it, in a region around it, it's got to be continuous, and the partial respect to y is to be continuous. Right? Yeah.
Before being on the test, explain why x equals 0 is an ordinary point. Can we just show that Q of x
No,
What do you want us to show?
no, it can be equal to 0, that's fine. It just has to be continuous and differential at that point. So you just need to check those two things. So once you divide by whatever the first, I can't remember if I gave you yeah, you divide by 1 minus x squared. P of x in that one is 0, because there's no middle term. So Q of x is 2 over 1 minus x squared. Two values make that discontinuous.
One and negative.
So the full-blown definition's gotta be analytic. For every function we're gonna look at, that really means continuous and differential.
So if you plug in 0 and it's like constant, for example, is continuous.
Yeah, when you plug 0 in there, it's continuous and differentiable at 0.
0. Oh, for the original.
It's only discontinuous at 1 and negative 1.
Would that be for Q of x or just the original? Like,
Both.
oh, okay.
So if there was a P of x, it'd have to be true for both of them.
When you plug in 0. That is.
When you plug in whatever point you're trying to say is ordinary.
Okay.
Yeah.
Or yeah, x.
So, for example, if P of x was 1 over x minus 3, and Q of x was 1 over x minus 5, then 3 and 5 are both single points for different reasons, right? Because so both of those have to be continuous and differentiable at the point that you're considering. Does that make sense? You know, you're all like, as much as anything else does. Okay. I know this practice test, I kind of purposefully made it a beast, but I don't mean it to be representative of what your final's gonna be. My philosophy with practice tests are always like practicing with a slightly bigger basketball. So when you start playing with the smaller one, you're like, holy shit, this is easy. Because you're used to getting that one that just barely fits in, so. So some of these problems could have been challenging. But don't take that to mean I'm gonna give you some insane thing on the final. I wanna give you as much of a chance to show me you understand the concept behind it, the problems. And if I hide it under all this extra shit that you have to wade through, I'm not giving you a chance to really show me you know how to do it. So I'm gonna try to make them more clear cut. I will have a couple of conceptual questions that kind of go deep. But the actual work problems, I need to make them a little more clear cut so that you're able to kind of like attack it and show me you know what the processes are. Okay. Is there anything else I wanted to say? And I'm guessing everybody was cool. You guys all remember this. We just sort of give up on the primes, so we don't end up with like 20 primes up there. Yeah. 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 Okay. I think I jammed this in at the bottom of the. Did I put that one on there? Oh, good. Yeah, it's way at the bottom of this. I did it a little quickly, but just in case you guys are doing this section, the whole idea is once you get lambda, that is the powers coefficient of E, because we focus on constant coefficient problems for doing this, so that we get a nice constant matrix. You guys are all with me? So in case you want to do the extra credit section, this is the interpretation of the results down here. There's your 1, 1, there's your 2, 1, right? Okay. And again, if you haven't taken linear, that might look very weird, I understand.
How you doing, Jeff? No one asks you that, you know?
No.
They always ask you for everything but how you doing, so how you doing?
I am, I'm okay.
Is that really how you feel?
I feel bad, because because this semester I had to take an extra class on, for reasons. So, I feel like I didn't have as much time, sorry.
Alright.
Just some, sorry.
Take your time.
Some family issues I'm trying to help. So, just teaching one too many classes. So I feel like I wasn't able to do as much as normal.
Oh my god, you're gonna make me cry.
Sorry. No, it's all right.
I feel like I've been able to absorb more this semester than I did even last semester. I really appreciate you helping us. You did a great
Yeah.
job.
Huh?
It's one of the best I've ever done in a math class, so.
You did great. You're doing great. Yeah. Yeah, I'm sorry, guys. I don't mean to.
No,
It's
sorry,
alright.
man.
Don't be
sorry, man. It's alright.
It's interesting because so part of it is I know I'm very hard on myself, and I never know what it's like from your perspective. So to me, I normally would have done more. There's more stuff I wanted to research and kind of bring in. But I think it came out okay. Sorry. It's just, students are the same way. Students, you guys have a lot of shit going on. But always remember your professors have the same thing. I'm really sorry about this.
Thank you.
But, yeah, sorry.
Can I just say, like, I don't want you to be sorry. If anything, this is like so nice to see from a professor.
Yeah, it's kind of silly. Me, I can only speak for me, but sometimes I feel like I need to, like, be, the teacher, I gotta be in charge, I gotta be, but all of us are human. We all have different things happening. So, anyway, it's gonna be okay. So obviously things have gotten to a good place. So I'm not sad right now. Everything's better. Everything's better with my situation. So for a while it seemed a little weird, with some stuff going on, but it's all kind of stabilized now. Mostly I'm just sad because I feel like, again, wasn't able to grade as much as normal, and do a lot of things. Sorry.
If you need a hug, be honest.
No.
You need a hug?
It's kind of funny because I didn't realize I was like this emotional while I was, but teaching means a lot to me. This class means a lot to me. A lot of you guys mean a lot to me. So I just want to make sure you get the best experience with this. And if it was a pretty good experience, great. That's great. But I just feel like you could do better. But
You can't be mathematically perfect, sir. You're doing great. There's a beauty in the flaw.
yeah,
You're
there's
doing
an
great.
asymptote there, that perfect thing. Yeah. So. Yeah. That's why he's like, holy shit, that's one question.
Hey, no. Hey, that's how you really feel. Hey, if that's how you really feel, that's what I asked.
That's true. That's
That's
true.
what I asked. You answered.
And I appreciate some of you guys. For those of you who don't know, we had a board meeting where the math department had a statement about. I think I talked to you about AB 75, AB 75, where they eliminated. We can't teach intermediate algebra anymore. Now they're making it so that we can't teach pre-calculus anymore. Yeah. So that's been kind of going on also in the background. So it kind of like really just puts a dagger into my whole freaking life because that's what I'm all about. It's math education, and now you're taking away the tools that I can give a student. It's like, what the hell? Anyway,
How are those students who don't take that before high school, how are they supposed to keep on doing?
so what kills me is we'll have a discussion about this. This is necessary. This is good. This is equity. This is going to help students. And then we have a workshop about how do we get more STEM students? What do we do? And like, were you listening to yourself? You just took a major avenue for STEM students to actually get into their degrees. You took it away, and then you're going, man, we got to figure this out. How do we get more STEM students? Anyway, so some people spoke out. Some students spoke out at the board meeting, which was awesome. They're also trying to make class caps go away and make classes go up to 60, students. They say it's because it's good for students. They say it's because, it'll help retention, it'll help grades. No, it's the budget. Just say it's the budget. Just say, we gotta save money. Just say that shit. Even better, have a discussion and say, hey, admin budget. Holy shit. Yeah. Sorry. Sorry, we gotta sleep professional. It doesn't matter. So there's a lot going on, just kind of like at a head this semester. So it was in my job and in my personal life, so it got a little crazy. So I'm hoping you guys got a decent amount out of this class.
Been great, thank you.
Okay. Let's see, what do we got? 5 more minutes to watch stuff, Brian. Anything? Anything else we want to focus on?
Just about one.
Teach us about the history of all mathematics.
Yeah, it's funny. I want somebody to go, I just have one question. How did all this stuff, how did this come about? Who cares? Who cares? Yeah. Why do they care? Okay, well, if you guys have no more questions, we can.
Do you know why the method works with the factoring? Like why that?
Oh,
You know why it works, or you just?
yeah, let's see. All right, I'm gonna push it up here. So, the whole idea is, I'm almost certain you guys have done stuff like, I know, thank you, Bill. Have you guys stuff like, for -6, you start rearranging the factors to get this to work, like you'll do 2 times -12, right? And you'll kind of do it until you get, so then you get 3, take a 4, add a 4 there. You know, so you play with the factors. So that's basically all this is that if I slide some factors of this over to the end, I've got to slide the factors over to the beginning at the end. So it's literally just, when you do this, all I need is for this to be -8. And all I need is for this to be 3, yes? So if I put a 2 there and a 4 there, this is still -8. But also this is -6.
So it's still the same grouping of numbers, just.
So it's kind of like, this would give me a -5x. This would give me a -5x. A bunch of shit would give me a -5x in the middle. But I can just slide enough over to get what I need. Like I need the -6. So this would give me a -5x in the middle, yes? But it wouldn't give me the -6 I need. So it's whatever factor I roll over, I've got to take that factor back. Yeah. Anyway, so.
Thank you.
Sure. It's unfortunate. I'd love to teach a class that I would call fall through the cracks math. Where stuff like that, it's just so easy. There's no time. So there's all this cool ass shit that's right on the sides of all the stuff we do, and we just never have time to even talk about it. Which is why you guys should all just play with math. You make your own shit up. Right? Just play with shit. So the more you know math, the more you got stuff to play with. And that's how there's theoretical mathematics is all about just playing around with math, and then physics sometimes goes, hey, what was that thing? Hey, that thing. Yeah, the thing you just scribbled and played with, I need that shit, right? So that's happened. I mean, we figured something out 20 years ago that was just playing around. Way to go, Doug. Good use of your time. And then later it's like, oh wait, that completely helps us figure out the theory of everything. You know, it's insane. Okay. What a weird place, right? Okay. Anything else? How you guys doing? Alright. I just want you to know, I know each of you have a lot going on in your lives. So everybody does. And as a teacher, it's really difficult because it's a weird balance you have to have between maintaining expectations but also communicating, just talking to you if something's going on, and then relaxing some of those sometimes. And not every student really understands that that's true. You just have to talk to your teacher, but, some teachers are assholes, I agree. But you have to try, you have to talk. So I appreciate those of you who come to me with issues over the semester that I could try to help with. Cause you don't always have the time to do so. Yeah, otherwise, if you don't come one-on-one, it's hard to figure out what to tell somebody until I know your situation a little bit better. Yeah. So anything else? Okay. Alright, if that's it, we can head out. So you come to my office hours that I got up there, somebody can remind me of two things, web assign chapter 8, and put my next week's schedule up in Canvas. That'd be great. I'm gonna bring snacks next week. That I'm gonna eat myself, you can watch me. No, I'll share some of it with you. So we'll have some snacks. Okay. Free food, yes, I know. I remember being a college student, free food